Okay. Thank you very much for the opportunity to present about this topic. It's a project that the Water Resources Group has been working on for about 2 years, and it just was completed about a month and a half or 2 months ago. The title of the talk, as you can see, is Sebago Lake and the Water Quality Index. The three of us from the Water District who are most involved with this project are myself and Nate Whalen and Kirsten Ness. Kirsten, who is right over there. Nate's not here tonight, but they were very fun. They actually, Nate and Kirsten did much more of the heavy lifting than I did. I just get the honor of telling you about it. There were also many other project partners, which I will, is all here on the next slide. Because the project was a collaboration of the district and these other very important partners. And in addition to the district, the project was managed by the Cumberland County Soil and Water Conservation District. We have partnered with them on a number of occasions. This was a different kind of project than we normally partner with them on, but they were sort of the lead scientists and project managers. So we were on the team. There were also several staff members from the Maine Department of Environmental Protection who contributed in important ways. The Lakes Environmental Association from Bridgeton, they contributed a lot of water quality data and also expertise. We also partnered with a professor and her students, Firuza Pavri from the University of Southern Maine. And it was funded, the project was funded in part by the EPA. There wasn't any EPA staff on the project team. The names of all the project team members are there on the right, but EPA provided ultimately the funding, a big piece of the funding came from EPA. This is just an overview of how the presentation is put together. Because I gave this talk most recently at the North American Lake Management Society meeting, I have some background information that will be much more familiar to all of you, but it doesn't go too much in depth, but it just introduces Sebago Lake. So I'll go through those slides relatively quickly. Then I'm going to talk to you briefly about EPA's 319 program. 319 refers to Section 319 of the Clean Water Act, which is how this project was funded and why it was funded, in fact. And I'll explain all that in that section. The main part of the talk is the next part, which is the method that this group came up with to evaluate the watershed of Sebago Lake and determine essentially where can we get the most bang for our buck? Where would be the best place to do work? If we have limited resources, where in the watershed is the best place to do work? And that method that the group came up with is the main part of the talk. And then I have some sort of final thoughts, and then I'll be happy to answer any questions that you have about all that. Stopped advancing. Okay, so again, this was for an introduction for a non-Maine audience. I often say, maybe just to start a discussion, that Sebago Lake is Maine's most important natural resource. You say that, and then immediately people start getting defensive about their particular natural resource. But I'll explain to you what I mean by that. That Sebago Lake is surrounded by some of Maine's most valuable summer and year-round homes. So there's development around the lake, which is very valuable, and the value of that development is in part based on the water quality of the lake. Secondly, there's a number of very important beaches and other access points, so it's very popular for people for recreation. Oh, now it went backwards for some reason. Okay, and then there's also 11 marinas that circle the lake and many hundreds and hundreds of boaters, thousands that value Sebago Lake for recreation and fishing. And then finally, as you all know, it's the drinking water supply for 200,000 Mainers. So when you take all that in together, you realize that it's a resource that does a lot of things for a lot of people. And again, that's why I sometimes argue it's the most important natural resource in Maine. Even if it doesn't win that contest, it's certainly in the running for that title. So now I'm just going to sort of fly above the lake for a minute and sort of set the setting for the presentation. So here's Sebago Lake. It's 30,000 acres in area, which makes it the second largest lake in Maine in terms of its area. It's also on average 100 feet deep. At its deepest point, it's 305 feet, but the average over that whole area is 100 feet. So if you have an area and a depth, you can multiply those together and get a volume, and then you can convert that to gallons. And when you do that, you get nearly 1 trillion gallons of water. So as we're all sitting here, 20 miles or 10 miles away, there's 1 trillion gallons of water sitting there, making it, certainly a quantity of water that's adequate to meet our needs for many, many years to come. It also is very...
Ask a question, follow up to that. Then what is the definitive safe yield then of the lake?
That's an engineering question. So luckily for me, I have several engineers in the room. It depends on how you engineer the system. So I think there's a limit now based on how our system, you correct me if I'm not right on this, there's a limit now based on how our system is configured, but if you needed to get more water out of it, you could engineer the intakes differently to get more. Is that a fair answer?
It's not about, we haven't pushed the safe yield in terms of a hydrologic sense. It's more about where we come to it is from a permitting sense.
Yeah, I guess that's my question. From a hydraulic sense, what is our hydraulic sense? What is the bracketing of the usage or safe yield?
I'm not real. I will embarrass myself if I try to answer that. And we use 20, so we're well below what's considered the safe yield. But I think if you needed to get more, I mean, there's more water there than that. It's just that's the number that we've put out there. It's all, in addition to being a quantity adequate to meet our needs, it's also very high quality, as shown by this chart. The red dots on there just show you the transparency of the lake by month, every month since 1975. We've been measuring this. The lower on the chart that the red dot is, the more transparent the lake was that month. So it goes up and down, but generally it averages 10.6 meters in depth, meaning you can lower a disc 10.6 meters into the lake and you can still see it on average over a 40-year period. And you can see that most Maine lakes, most of which are very clean and you'd be happy to swim in them, average 4 to 5 meters in transparency. So Sebago is, certainly by that measure and by almost any other, one of the cleanest lakes in the state. As you all know, to get that water from the lake to our 200,000 customers, we have this network of pipes, much of which is shown here, 1,000 miles of water pipe, which we use to get the water from the lower bay of the lake to our customers. But that's not the water network that is the subject of this presentation. If you look at this graphic, is it not advancing anymore? Okay, so what you see now on this graphic, there's the lake, there's our entire 1,000-mile water network, but then this area up here, which is outlined in yellow, is what's known as the watershed of the lake. So that's all the land that ultimately drains to Sebago Lake. So what happens on all that land matters to us because eventually it all reaches the lake. There's another water network, which is more extensive than our 1,000-mile water pipe network, which now I'll show you what that looks like. That's all the rivers and streams and ponds and lakes that are in the watershed that carry the rainwater that hits the watershed all the way down ultimately to Sebago Lake. And that area is the subject of this presentation. Okay, so you maybe have heard this and you've seen it in your trustee packets, 319 projects. What that means and why we refer to them as 319 projects is there's a section of the Federal Clean Water Act, which is Section 319, and under that section, among other things that EPA does, they provide grants to the states, and those grants can then be applied for by entities like us or soil and water conservation districts or lake associations to do what they call non-point source work, which in simplest terms is erosion and sedimentation control work. So there's money that's made available each year by the DEP. They get money from EPA and they make it available, and you can apply for that money to do erosion control work. And we have been doing that many, many times, 15 or 20 times us alone, being one of the primary partners on a project over the last 15 or 20 years. So to show you how extensive our access and our use of those funds has been, this graphic shows you the Sebago Lake watershed broken up into smaller pieces, which I'll explain in more detail. We call that subwatershed. So it's essentially just taking this whole area and breaking it up into bite-sized pieces. And when you do that, and then color code which subwatersheds we have already done 319 work in, either us as the primary grant recipient or as a partner. All the ones that are bright green, work has been done in the last 15 or 20 years. There have been 41 319 projects in the Sebago Lake watershed in 19 different subwatersheds. And they've had an impact, because one of the things that you have to do when you apply for money through 319 is you have to quantify for the DEP, here's how many tons of sediment we will keep out of water bodies if you grant us this money. And when you add all that together, it's more than 800 tons of sediment that you can demonstrate through calculation you've prevented from reaching water bodies. So you might say, okay, if this is how the 319 has been going, what's the problem? Why was there a problem with this? And we certainly didn't have a problem with it. We were happy to do it. Well, the problem is, or the problem as EPA saw it, which then they convinced DEP to see that problem, and honestly, I've come to the conclusion that they were right, even though I didn't love the idea when they first changed it, is that we really didn't have a rigorous selection process for where are we going to do this work. In other words, the way it worked is organizations would contact us, like a lake association or Cumberland County Soil and Water or Oxford County Soil and Water, and they would say, hey, we want to do a 319 project around this lake. In other words, we want to do some erosion control work around Long Lake or Highland Lake in the watershed. Do you want to be partners with us? And we would always say, well, we love the idea. We'll bring it to our board and we'll ask them. And based on the premise that any project in the watershed benefits Sebago Lake, and if you want to do the project and you're going to pay most of the money and we only have to pay a little bit of money and get a lot of work, why would we be against that? So you've been voting on these projects for many years, and that's really was our logic behind it, is if we have to pay $5,000 and you're going to do $70,000 worth of erosion control work, where do we sign? So we were going along thinking this works fine. EPA kind of came to the conclusion, I guess, that they were granting money without really knowing, is this really the best way to spend this money, or is it just the way it's going? So they changed the rules, and DEP followed suit and said, okay, from now on, before you can apply for any $319, we want you to do what's called a watershed-based protection plan. In other words, we want you to show us how you're sure that this is the best place to spend money on erosion control in your watershed. So in other words, prioritize work so we can know that when we issue a grant, it'll be doing the most good. So now I'll just be honest, this is true confessions. When I first heard this, I said, all right, let's do a plan. They need a plan. Let's get it done as painlessly as we can and get back to what we were doing. It took me about a week to realize, well, wait a second, if we're going to spend time and do a plan, let's do one that makes sense to us so that when we're done, we can be more confident that the work we're doing is better. And the plan that they, or the template that they had, really didn't fit very well into a 450 square mile watershed. It was kind of designed for a lake association to work in a small watershed. So when we tried to apply it directly one-to-one to the Sebago Lake watershed, it became kind of unmanageable. So we set out to come up with a new method, and honestly, then the hardest challenge was convincing DEP to let us do it this way instead of the way that is in this kind of template plan that they have. But ultimately, they made some changes, we made some changes, and we came up with this method. So now that's what I'm going to explain to you, because in the end, DEP loved what we finally did, and we love it too. So this is what the method consists of. It's in 5 parts, and I'll just go through them quickly here, and then I'll break them down one at a time. So the first thing we had to do was define the subwatersheds. In other words, you've got this 450 square mile area. How are we going to break it up into smaller pieces? I'll explain that briefly. The next thing we did is we compiled existing data. The grant was for about $35,000 from DEP, and then with match from other sources was about $75,000 total. And that's not enough money to go out and collect a lot of environmental data. You'd run out pretty fast. So we had to use existing data, some of which we had, some of which the state had, some of which Lakes Environmental Association had. So we compiled all that data. And then what we did is we ranked each sub-watershed using 4 metrics from that data. And I'll show you what that looks like The last thing we did, this was a DEP idea, and when I first heard it, I had never really heard of this before, but one of the limnologists at DEP insisted that we include what he called a sensitivity analysis, and I'll explain to you what that is, and it really was a great idea that I never would have thought of. And then finally, and this is, I've been in environmental science now for 25 or so years. I've been on a lot of project teams, which are often a group of scientists who sit around and kind of think things through and then analyze something. And then the only people that really can understand it are the group of scientists and maybe their colleagues that are similarly trained, and that it's not really that understandable to the general public. And so this team, we spent a lot of time trying to figure out how can we explain the results of this analysis, because part of this is to spur erosion control work, which requires local buy-in. And so if we can't explain what we did to the average person, we're not going to have much success with that. So we spent a lot of time coming up with a way to communicate the results, and I'll show you what that looks like. So those were the 5 steps. So now I'll go through them one by one. So the first step was to divide the watershed, which you can see the larger area, into smaller pieces. Okay, it's a little bit of more detail than you need to go through how we got to this. This is what the final subwatershed map looked like. But essentially what we did is we started with the U.S. Geological Survey has already subdivided all the watersheds of the United States up into smaller pieces that they call HUC watersheds, which if you're not in environmental science, you may not have heard that term, but you could contact the USGS today and they could send you the data for your watershed. Here are the subwatersheds, the HUC subwatersheds. And we started with that, but it turns out that that didn't work well for our project. So in some cases we combined some of them, and in some cases we divided them further. But the essential goal in all that subdividing was so that each subwatershed would have one lake in it. So if you look on here, you can see here's a lake, a lake, a lake. And that works really well for our analysis, because one of the measures of what's the condition of this subwatershed is what's the quality of water in that lake. So it just made it much easier if there was only one lake in each subwatershed. So to do that, you had to kind of subdivide and combine. But this is what we came up with. So there's about 34 subwatersheds that combine to make up the 450 square miles of our watershed. Okay, so the next thing was what data is available free that we can use to evaluate each subwatershed and then compare them to one another. So here's what we came up with. First of all, as I said, one of the first things we thought made a lot of sense is if the lake within the subwatershed is very healthy, that's a pretty good indicator that whatever the condition is of, there can't be a whole lot of erosion and other problems if the lake is very clean. So it turns out that virtually all the lakes within our watershed, somebody's monitoring it, and so there is some water quality data. So we started with that, and we looked at the water quality data in 2 different ways. First, we looked at what's the present water quality, and then we looked at what's the trend over the last 5, 10, 15, 20 years. Because you might have a lake that's in pretty good shape, and if you just looked at the water quality today, you'd say, that's pretty good. But what if it was a lot cleaner 10 years ago? That would be an indication that something is changing and it's getting worse and something you may want to work on. So we evaluated each lake, both the present water quality and how it's trending. The second thing we did, and the symbols you see are which of the partners was most critical to getting this done. In the case of land use data, it was the University of Southern Maine, and then some computer time at the Cumberland County Soil and Water Conservation District. But what we did was we used Landsat imagery, and USM has access to this data and knows how to process it. So satellite imagery of the watershed, looking at each subwatershed and seeing how has it changed over the last 25 years. The next thing we used to evaluate them was partnerships, which is kind of an odd thing for scientists to do, but this is kind of, if you're going to do lake protection work, you have to have somebody who lives around that lake to work with. And so one of the things we looked at is in each subwatershed, what group or groups or people that we know are interested in lake protection and have done it before, have done this kind of work, the more there are, the better success we're likely to have working in that subwatershed. So for each subwatershed, the Cumberland County Soil and Water Conservation District evaluated each one to see if they could name partners in each one that they've worked with in the past. And if there were more of them, they got a higher score, and if there were less of them, they got a lower score. I think there's one more. And then finally, as I told you, I'm going to explain what DEP meant by a sensitivity analysis, but it was mostly the DEP and then Kirsten and Nate from the Water District that worked on that. Okay, so now I'm just going to explain in a little more detail the 4 types of data that we use. So for lake water quality data, I'll explain what I mean by this, but the trophic state index of the lakes within the watershed is what we use, and I'll explain what I mean by that. For land use data, it was Landsat imagery. For partnership data, it was previous work. And then for sensitivity data, essentially the question was, this is what the sensitivity analysis is, how much phosphorus from this subwatershed actually reaches Sebago Lake? Because phosphorus is often the nutrient that you evaluate to determine to evaluate lakes in a subwatershed. But the question essentially is, if you have 2 subwatersheds and they both decline and they get enriched in phosphorus, they don't necessarily both have the same impact on Sebago Lake, because if one is further away, for example, it's not likely to impact Sebago as much as one closer to the lake. So I'll explain that in a little more detail. So the 4 metrics that we use to evaluate each subwatershed are shown on this graphic. First, we looked at the current water quality conditions. Then we looked at how it's trending over time. Then we looked at how the land cover in that subwatershed has changed. In other words, how many trees have come down in the last 25 years. And then finally, how many active partners are we aware of? Okay, so I told you that trophic state is the measure that we used within each subwatershed to evaluate the water quality of the lake. And what trophic state is this. Lakes over time they have a sort of an aging process like people do. And they start out generally cleaner, clearer, with cold water fisheries and few but healthy and plants. But over time, as more and more nutrients wash into the lake, and this, by the way, happens faster if you take down all the trees around the lake, but even a lake that is not even a watershed that's not developing, over time a lake will get enriched in nutrients, the fisheries changes, you get more warm water species, you get more plants, and then finally the lake itself can reach a point where it's actually blooming with algae when it's got a very high trophic state. So typically, in Maine, lakes are evaluated based on their trophic state from low to high. Low is better, high is worse. It's a natural process, but humans can speed it up so that it happens in just a few years instead of a few centuries, for example. So we have water quality data from lakes all throughout the watershed, and we can evaluate the trophic state. And there's a number there's a formula or a calculation that you do, and you come up with what's called TSI, or trophic state index, which is just putting a number on this measure. The lower the number, the better. Sebago Lake is around 30, which is a good low number. Some lakes can get up as high as 60 or 70, and those lakes would be green. You'd know the difference. Okay, so looking at current water quality conditions, as I said, the lower the trophic state of the lake in the subwatershed, the better. And so what we did is we took all the lakes and we ranked them from 1 to 5, 5 being the best and 1 being the worst. When we did that, then you can see that we were able to color each subwatershed with a color. The bluer it is, the better. And so you can see that most of them are either very dark blue or lighter blue. There's a few that are greener and a few that are sort of yellowish. But overall, if you, sort of the take-home message is that the good news is that when you look throughout our entire watershed, and these are all lakes that are draining ultimately to Sebago, so the cleaner they are, the better off we are, that 60% of the subwatersheds have lakes with a trophic state under 39. And 39 is a good low number. 30 is better than 39. But to know that most of the lakes that are emptying and the water is draining into Sebago Lake have a low trophic state is good news for us, because the higher the trophic state was of those lakes, the more phosphorus they would be exporting to Sebago Lake. So that was a good thing to find out, which we didn't really know before. Then we looked at how they're trending. In other words, you could have a low trophic state, but if it's trending down, that's not a good thing. And when we did that, essentially what we did is we put the lakes into one of 5 categories. 1, or green, means that the trophic state is significantly increasing, which means water quality is declining. And then 5 is that the trophic state is actually decreasing, which does sometimes happen, that over time a lake actually gets clearer and cleaner. And so then we looked at each lake in the watershed, and we colored the subwatershed based on this. And again, I want you to notice that there's a lot of blue there. That's a good sign, because that means throughout the Sebago Lake watershed you have lakes whose trophic state is either improving, or it's stable, or it's either improving or it's stable. There are very few where we can find evidence that the lake is declining in quality over the time period that we have data. Now, some of them we only have 5 or 6 years of data, and others we have 10 and 20. The longer the period of record, the more confident you can be in that prediction, but it's still a good sign that we did not find a lot of lakes. I think there's there are only 23 subwatersheds that we had enough data to do this analysis. So we couldn't do it for all 34, but the 19 that we could evaluate, of the 23 we could evaluate, 19 of them have either a stable or an improving trophic state. So that's all water that we can expect to come to Sebago Lake over the next 5 and 10 years, so that's a good thing. Okay, so after we evaluated water quality in the lakes, present and trending, the next thing we did is we looked at how much is the land cover in that subwatershed changing. Because if over the last 25 years a lot of trees have come down and a lot of houses have been built, you can kind of predict that over time the water quality is not going to get better. It may get worse. So what we did is, this was a USM project that they took satellite imagery from 1987 and then satellite imagery from 2013 and processed it to evaluate how much green cover can they see. So that when you're using satellites to do this work, the size of an individual pixel is 30 meters. So it's not real detailed. You can't zoom right down and see someone's house, but you can, from that distance, you can see patterns overall of how much is green and how much is not green. A parking lot would show up. So when they did that, we then were able to look at each subwatershed and say, within that subwatershed, is it getting more green over the last 25 years or less green over the last 25 years? And obviously, any subwatershed that you're seeing more and more tree cover and ground cover over the last 25 years, that's a good sign and probably indication that that's not a subwatershed to worry about. One that's more green is one where a lot of trees seem to have come down based on the satellite imagery. And when you do that, again, this is also not quite as favorable as the water quality data. There has been some development in the watershed over the 25 years or so. But the ones that are green are the ones that show the most percent change in land cover over the last 25 or so years. The bluer ones have less change. And the mean change, in other words, the average for the whole watershed is 1.65%, meaning that's how much cover has been lost over a 25-year period. And then the last thing we did is just, do we know anybody, if we needed to go work in that subwatershed, do we know who we can pick up the phone and call, and they'd say, we're ready to take action. And we ranked them, again, into 5 categories. And when we did that, again, you can see, and this is based on the fact that we've done a lot of 319 projects already. When you do that, that means you've worked with a lake group or you've worked with a town, and so we already kind of know who we would call in most of the subwatersheds if we wanted to do work. There's a few that we don't have a lot of partners that we know of, or Cumberland County or any of the other partners in the project, so those are ones we maybe want to do some outreach to and see if we can identify who lives there and how interested they are in lake protection work. So most of them are high or medium high. That's good news. Okay, so again, what we did is we ranked all the subwatersheds with those 4 measures to see which ones appeared to need work the most and which ones the least. And then we did what I referred to as a sensitivity analysis. So here's the concept. You have a lake of interest, and it has a watershed, so that is shown by the yellow line. So this is all the land around the lake that drains into the lake. Within that watershed, there are other lakes. So here's Lake A and Lake B. Lake A is bigger than Lake B. They each have their own subwatershed. So here you go. Lake A has a bigger subwatershed than Lake B because it's a bigger lake, which is common. So each of those subwatersheds then drains, runs